Back Algebra 2. Today we're going to talk about something called binomial expansion. So this is 3.3b. And before we talk about binomial expansion and Pascal's triangle, I want to talk to you for a minute about why this comes in handy and why it's important. So sometimes we have equations like this, okay, a binomial to the fourth power. So let's see what we get when we multiply x plus 3 to the fourth power. So we're going to do x plus 3 times x plus 3, and it has to be 4 times x plus 3 times x plus 3. So I'm going to start out by FOILing my first two. So first, outer, inner, last. So now I'm going to combine my like terms. Now, in this case, if I FOIL my next two, I get the same thing. Now I have to multiply these, so I can use my box method, okay, or I can use my distribution method. Okay, but whatever method, now I'm going to have to multiply these two trinomials together to get my final answer. So this is just to the fourth power. Sometimes we have something to the 7th, 8th, 9th, 10th power, and it takes a whole lot more work than just this. Okay, so binomial expansion is a shortcut. It really helps us out, and we'll talk about another shortcut when we get to permutations and combinations. So our statistics chapter, we usually talk about that. So Pascal's triangle is a triangle where each number is the sum of the two numbers diagonally above it. All of the outside numbers are 1, and the top is considered row 0. Each row down is another row. So we're going to create the first 7 rows of Pascal's triangle. So we always start with a 1. So 1 on each side. Okay. So now we need to add those two together, and that's a 2. So that's going to be our middle number, and our outside is always 1. Once again, our outside is always 1. To get our next number, we're going to add these two numbers together, and we get 3. We're going to add these two numbers together, and we get 3. Then our outside is always 1. We're going to add these two numbers to get 4, add these two numbers to get 6, add these two numbers to get 4. And we keep going. So 1 and 1. Add these two numbers together to get 5, 10, 10, 5. Okay, let's see what row we're at. The most important thing to remember is that the first one up top is always the 0th row, okay, row 0. Then we have row 1, row 2, row 3, row 4, row 5, row 6, and we're going to do a 7th row. So I'm just going to add my ones again. So 1 plus 5 is 6. 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. You can go ahead and do the last row by yourself if you haven't already, and then check it with me. So 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 15 plus 20 is 35, 15 plus 6 is 21, 6 plus 1 is 7. Okay. Now notice that these numbers repeat as we go across the rows. Okay. Pascal's triangle is actually pretty handy. It's used for quite a few things. The only thing we're going to talk about it being used for right now is for binomial expansion. Okay. So each row of Pascal's triangles actually gives the coefficients of the corresponding binomial expansion. So the pattern in the table can be expanded to apply to any expansion, to the expansion of any binomial. Okay. So a plus b to the n power, where n is a whole number and it's one of the rows, or it's the row number for Pascal's triangle. So if we have some number to the 0th power, okay, some binomial to the 0th power, Pascal's triangle, it's a 1 in that 0th row, which means our binomial expansion is 1. To the first power, okay, these are our coefficients and our variables. Okay. So the biggest thing we're looking for here is for our coefficients. And then I'm going to walk you through some tricks to use this. Okay, so the easiest way I think to use this and learn it is always to do some problems. So we're going to take a look at x plus 3 to the third power. So that really means x plus 3 times x plus 3 times x plus 3. Once again, this one might be easier to do using just basic multiplication. But once we get into really big ones, it's a whole lot easier to use the binomial expansion method. Okay, so the first thing I'm going to look for is the third row. Okay. So my third row, okay, consists of the numbers 1, 3, 3, 1. So my coefficients for my polynomial is going to be 1, 3, 3, and 1. Now, the way I do this is we always start from left to right. So we start with x to the third power. Then it goes to the second power. Then it goes to the first power. And then it goes to the 0th power, which means it's not there. Our y term or our b term over here, we start with over here to the third power. So we're going to work it backwards. So that's going to be 3 to the third, 3 squared, 3, and no 3. Now I'm just going to add some plus signs in here. They may change based on the sign here. So this is a positive 3, but sometimes these signs change. And now I'm just going to go ahead and I'm going to do the math. Okay, so 1x to the third stays 1x to the third. 3 times 3 is 9. So that becomes 9x squared. 3 squared is 9 times 3 is 27. So that becomes 27x. And 3 to the third power is 27. So that becomes 27. Now you can see, since this is to the third power, my polynomial has to have to the third power. And my 4 terms right there. Let's go ahead and take a look at another one. Okay, so x minus 2 to the 4th power. So it's the 4th power, which means I'm going to use my 4th row of Pascal's triangle, which if it's not given here, okay, you guys need to be able to create it. Okay, so that's 1, 4, 6, 4, 1. So I'm just going to write out those numbers. I'm going to draw a little line here. Okay, so that's 1, 4, 6, 4, 1. And then I'm going to start with my a term, my x, to the 4th power on the left. Then to the 3rd power, then squared, then to the 1st power, and then it's not in the last term. And now I'm going to do my -2, starting on the right to the 4th power. So -2 to the 4th power, -2 to the 3rd power, -2 squared, -2, and no -2. Okay, so they cross in between. Okay, so now let's go on ahead and do this math. So 1x to the 4th is just x to the 4th. -2 times 4 is -8. So that's -8x to the 3rd. -2 squared is 4 times 6 is 24. So that's plus 24x squared. -2 to the 3rd power is -2 times -2 is 4 times -2 is -8. -8 times 4 is -32x. And -2 to the 4th power is 16. And that's our final answer. Let's go on ahead and try a different one. So 2x plus 5 squared. So using binomial expansion, I'm going to find the second row. Remember that my 1 at the top is always row 0. Okay, so this is row 0, row 1, row 2, row 3, row 4, row 5. Okay, so row 2 is going to be a 1, 2, 1. So I'm going to write out my 1, my 2, and my 1. And I'm leaving a little bit more space between these because I'm going to have just a little bit more to write. I always start now with my first term on the left to this power. So that's going to be 2x squared. And then that's going to be 2x, and then no 2x. Then I'm going to start with my b term on the right to this power. And then it's going to lose a power every term. So 5 squared, 5, and then no 5. Okay, so now I'm going to do this math. 2 squared is 4. So this becomes 4x squared. 5 times 2 is 10, times 2x is 20x, and 5 squared is 10. And notice that my exponent there is also my degree here. My exponent is to the 4th, my degree is to the 4th. My exponent is 2, my degree here is 2. As long as there's no exponents inside there, that's going to be the case. They're going to match. Go on ahead and try this next one. Pause the video, try it, and then come back and check your answer with me. Okay, I hope that all of you tried this. So we're going to go on ahead. First thing, we're going to look at the 4th row of Pascal's triangle, which is right here. So that's going to be a 1, a 4, a 6, a 4, and a 1. Now I'm going to start with my a term, my 3x. My 3x, and it starts to the 4th power. Then it goes to the 3rd power. Then it's squared. Then it's to the 1st power, and then it's not in my last term there. And then my -2 or my -2 starts as -2 to the 4th power, then to the 3rd power, then squared, then to the 1st power, and then it's not in that term. Okay, so now we're going to go on ahead and do the math here. So 3 to the 4th power is 81. So that's going to be 81x to the 4th power. Now I have 4 times -2 is -8, and 3 to the 3rd power is 27. So that's going to be -8 times 27, which is -216 x to the 3rd power. -2 squared is 4, times 6 is 24, and 3 squared is 9. So 24 times 9 is 216 x squared. My next term here, -2 to the 3rd power is -8 times 4 is -32 times 3 is -96 x, and then -2 to the 4th power is +16. The one thing that some of you might be questioning, that I am very sorry that I didn't explain this, or I may not have explained it better. But here I put my plus signs on these. I neglected to. I oftentimes run out of room when I'm doing these. Okay, so there should be pluses between every one of these coefficients, okay, at the beginning when you start, because you're adding these terms, okay? So keep that in mind. But that is it for 3.3b and binomial expansion. Make sure that you're asking questions, and have a great day.